Show that p minus 1 is a factor of p to the power of 10 minus 1 and also p to the power of 11 minus 1. So what is the funda that we have to use? We have to use factor theorem. What is the tell? Once you figure out the remainder, if the remainder turns out to be 0, then it's a factor. If it's not, then it's not a factor. That's all. So basically, we have to figure out. Okay, so here we have to be careful. All the variables are p. So we'll go with v of p, u of p, and d of p. There are three expressions, right? So v of p is your p to the power of 10 minus 1, p to the power of 11 minus 1, and p minus 1. I'm just calling this with v, u, and p and all of that. You can call it with any name. You can just go with f, h, and g and all of that. Not an issue. Okay. So first is writing it in standard form. Next thing is, how do you find the remainder? Right, we have to figure out the remainder, only then we can decide as per the factor theorem. So basic idea is we have to figure out the 0 of the divisor and then substitute. That's it. Right? So let's figure out the 0 of the divisor. How will we figure out? We'll start with let t be 0 of d of p. So basically, if I equate p to be equal to t, my output will be equal to 0. Right? And now in place of p, I'm going to write t. So t minus 1 will be equal to 0. So we'll add 1 both the sides. So t will be equal to 1. Agree? Okay. So t is equal to 1. Next thing, we found the 0 of the divisor. All we have to do is substitute in place of p. So 10 to the power of 1 minus 1. So this is equal to 0. Right? Anything to the power of 1 to the power of anything is 1 itself. So 1 minus 1 is 0. And next we have u of p being equated to 1. So 1 to the power of 11 minus 1. So this too is 0. See, the question is show that. By default, the output has to be 0. Because they're telling it is so, you just have to figure it out. Show it. Not figure it out, show it. So now we got this output to be 0. So what? So as per factor theorem, right, d of p is a factor of v of p and u of p. That is your answer.